Welcome back. Having looked at E2, explaining E1 reaction is much easier. Okay, just like E2 had a lot of similarities with SN2, E1 has a lot of similarities with SN1. Okay, so your reaction is unimolecular, that is, it only depends on the concentration of the substrate. E1 reactions are not considered, that is, the reaction happens in 2 steps with an intermediate formation. E1 reactions are typically carried out in protic solvent conditions. E1 reactions are typically carried out with a weak bulky base, in contrast to a strong bulky base used for an E2. Now, you would probably hear or see this also written as T-butyl OH. Okay, this is called T-butyl alcohol or tertiary butyl alcohol. So in terms of formulae, this is how it looks like. In terms of another shorthand version of this is also written this way. So if you see that, it's the same meaning. Okay. And E1 reactions involves the formation of a carbocation, as just like you saw that for an SN1. And typically elimination reactions uses heat as a medium to carry out the reactions. And E1 substrate reactivity is just exactly like SN1. Tertiary substrates have a higher probability of undergoing E1 in the presence of a weak bulky base. And as with E2, Zaitsev rule is used to determine the stable product, which is much more important, especially for E1, because you will always have multiple products. So here is a reaction. Straight away, you look at the nucleophile first. This is a weak and a bulky base, and you have heat. And as I said, E1 reactions are typically carried out in protic solvents as well. And you have a tertiary substrate. All of this points to only one thing, which is E1. So what's the first step? Well, first step, the leaving group comes out, because it's a 2-step process, remember? So it results in the formation of a carbocation. Now, what is a carbocation? A carbon with 3 separate bonds and a positive charge. That's a carbocation. Now, carbocation is an intermediate, so we put it inside a bracket. This is the first step, right? What's the second step? Well, I'm going to do that in 3 separate ways here, okay? Okay. So if you notice, this is the carbon containing the positive charge. It's got 3 other carbons on either side, each containing at least 1 hydrogen, right? At least 1. This has 3, so we can use 1. Here it's got 2, so we can use 1. Here's got 3, we can use 1, right? So basically, each of these can be removed by the nucleophile to make the reaction go ahead. So what that means is, basically, this hydrogen can come off. So let's do one at a time, okay? So the nucleophile can grab this hydrogen, and so this bond could come here, resulting, as soon as the bond comes in, you will no longer have to have the positive charge, right? That's the one product. Or I'm going to say that the nucleophile can attack this hydrogen, and this bond can come in here, which then leads to the double bond being here. Basically, a double bond coming in, is a negative charge, which neutralizes the positive charge. Or I'm going to say that the nucleophile attacks this hydrogen, and the bond comes in, and so you will have the third product as this, right? Clearly, if you use Zaitsev rule, which one do you think is the most stable product? Both of these bonds are on the end, so they cannot be stable. This one is much more centered, So that means this will be the most stable product. So all you have to remember is with elimination, you cannot remove the hydrogen on the carbon containing the positive charge or the leaving group. It has to be the one adjacent to it. And that's all I have to say about E1. And here's something I have done, which is a summary. Okay, so given a reaction, first you look at, I've created a flow chart which will make things easier for you. First you look at the nucleophile or the base, whether it's strong or weak. If it is yes, you go to the left. If it is no, you go to the right. And then you determine, is the base strong? It's not only the base strong, but is it bulky and or heat present? If the answer is no, then you're likely going to have an SN2 reaction. If the answer is yes, then is the substrate tertiary. If the answer is no, again you will have an SN2. If the substrate is tertiary, yes, and then is the solvent aprotic? Well, if it is yes, then it's SN2. If it's no, then E2. So if it's a S, S, and a no, then it's E2. If it is not, if it fails even one condition, it's automatically SN2. Think of it that way. All right. And say if your base is determined weak, then you go to the right and you determine, is the weak base bulky and or heat present? Well, if it's bulky, right away we know it's an E1. If it's not bulky, if it's just a weak base like water or NH3, then we will have an SN1. Now, this is not telling anything about how the mechanism happens. This is just a shortcut way of remembering things. Okay. As a rule of thumb, I'll tell you, if it's primary and a strong base, it's highly SN2. If it's a tertiary and a strong bulky base, it's E2. If it's a weak base and a tertiary substrate, it's SN1. If it's a weak and a bulky base and a tertiary substrate, it's typically E1. And that's all there is. And if you just listen to what I just said in the last 20 seconds, I just basically captured everything that's on the screen right now. So this is just a flow chart. We will come back and use this over and over again in the class to really dissect this concept of substitution versus elimination. And I'll see you back with another topic.